Bismillahirrahmanirrahim. We are looking in this video at channelization. Okay, channelization. This is again a type of media access protocols, a set of media access protocols. In this case, the available bandwidth that we have, or the big frequency band that we have, this is shared in time, frequency, or through code, okay, among different stations. Remember, this is a multiple access, okay, method. It's a multiple access method. We are using this because we are having more than one computer or device using or sharing the same common medium, right? They are sharing the same medium. So we are coming up with all these solutions to make sure that all these devices can use the same medium without interfering with one another. Okay, without interfering with one another. So in channelization, we are now going to look at how can we literally divide the access to the channel. And in this video, we are looking at frequency division multiple access and time division multiple access. In frequency division multiple access, the available bandwidth is divided into frequency bands. Now let's see how that happens. So we said the shared channel. Okay. We have a big chunk of frequency. Okay, our shared channel. Now this channel, we are going to further divide it into sub-channels. Okay, we are dividing it into sub-channels. And each of these sub-channel, okay, each of these sub-channels will be allocated to a device. And each one of these devices will have access to this small channel all the time. Okay, so this is frequency division multiple access. Now there is a chance that C could interfere with F. It could by mistake send its signal in F's frequencies. So to avoid that, we have something called guard bands. Okay, these guard bands, they are unused frequencies, okay, and they act like walls. Okay, they act like walls, and they prevent two stations from interfering with one another. They will prevent the two stations from sending in the other's channel, sub-channel. Okay, so we have guard bands. We also have something called the band pass filter. Okay, we also have something called the band pass filter. The band pass filter makes sure that C will only transmit in this F will only transmit in this set of frequencies. B will only transmit in this set of frequencies. It will fine-tune, okay? It will fine-tune like the way we do to the radio to make sure that we are listening to one channel only, okay? We fine-tune it, right? So this is what the bandpass filter does. It makes sure it sets the channel for C and other devices accurately. They will all have their own bandpass filters. Okay, so this is frequency division multiple access. So each station is allocated a band to send its data, and each band is reserved for a specific station, and it belongs to the station all the time. Each station uses a bandpass filter to confine the transmitter frequencies, and to prevent interference, we have guard bands. So the diagram here shows that common channel being shared between 4 devices, okay, and each device has been allocated a sub-channel, okay, a sub-channel. So this was frequency division multiple access. We now look at the next one, which is time division multiple access. In time division multiple access, we are having the same frequency channel, okay? We have the same bandwidth in here, but instead of sharing the frequency, what do we do now? We are having the same channel okay, we're having the same channel, but now the whole channel will be allocated to one device for a small amount of time. Okay, you're allocating the whole channel to each device for a small amount of time. Before, what did we have? In FDMA, we had the big channel was divided into smaller channels, and a device could have access to that small channel all the time. But now it's different. Now we are keeping the channel the same, but we are dividing the time. Okay, so now we have A, B, C, D, let's say. Okay, so we could say A is going to have access to this channel for 20 milliseconds, and then D takes over, okay, and D will transmit for the next 20 milliseconds, and then C will transmit for the next 20 milliseconds, and then B, okay, and then you could also repeat the cycle again, and then A, and then D, and then C, and then B, and then A, okay, so it continues. So this is time division multiple access. You are dividing the big channel based on time. Okay, so this was the feature for TDMA, we said. In TDMA, we have to make sure that all these devices are synchronized. Their clocks should be synchronized so that they all start at the same time and end. Okay, they all sense the channel, and the clocks are the same. It's very important. Otherwise, you could have one device transmitting in the time of another device. So this is TDMA. So we have the whole channel. The entire channel now is divided time-wise, and every station is given a certain allocated time. Okay? It's like you could say a library book. When you go to a library, you can have access to the book, but not for all the time. You can have the book for a certain time, like a week, and then you have to give it back, and then someone else will take that book. Okay, so similarly in here, you're sharing the channel. So this was a completion of TDMA and FDMA.